Hello and welcome to this exercise on Pythagoras theorem and the circumference of a circle. Okay, this is an iGCSE mathematics example, high tier that is, and it's also suitable for GCSE high tier and for 10th grade geometry and for CXC mathematics curriculum in the West Indies. Now, I should try and paraphrase what we got here and what's given to us. Now, what we've got here is the drawing of a polytunnel. Yeah. Now, a polytunnel is a temperature-controlled environment in which plants and vegetables are grown. Okay. Now, in this particular drawing, we have loops, and the loops are all semicircular. For instance, your A, B, and C is a semicircle there. And we've got 20 of these semicircles or loops. Okay. Now, this polytunnel is strengthened by securing a high tension wire from the point A to the point D. Okay. The point A to point D. That's from there to there. Okay. Now, point D is at the 20th loop. So there are 20 loops, and point D is at the 20th loop. Now I couldn't fit all 20 in this drawing here, so I've got it shortened up. So point D is at the 20th loop, right? Now what we want to find is the length of this high tension wire from A to D. Okay. All right. Now to do that, first we need to find the circumference of the loop ABC, for instance. Now, the diameter is 4.8 meters because if we divide 4,800 by 1,000, you get 4.8 meters. So the diameter of this loop is 4.8 meters. Okay, so we need to find the circumference of this loop here, and because it's a semicircle, we have to divide the circumference by 2. So the circumference is going to be pi times 4.8 divided by 2. That's what we got there. And that gives us an answer of 2.4 pi meters. And there. Okay. Right. Now, we now want to find the length of the polytunnel. And because there are 20 loops, and there's a gap between 2 consecutive loops, so in effect, there will be only 19 gaps available. So the length of the polytunnel is going to be 1.5 times 19. So to go there, that will give us a figure of 28.5 meters there. Is a rectangle, so essentially of these dimensions there. Dimensions of the rectangle there and 8.5 meters there. Now, the diagonal is in fact the length of the high tension wire secured at A and D. So A and D. So that's what we're looking for. We're looking for this length here because that's the high tension wire secured from A to D, as in the diagram above. So to find that, we need to use Pythagoras. Sorry, we need to use Pythagoras theorem, and that says that AD squared is equal to 2.5 pi squared plus 28.5 squared. Now, if we take the square root of both sides, the square root of AD squared is AD, and then we find the square root of 2.4 pi all squared plus 28.5 squared. And that gives us AD of 29.48. Now, we want the answer to 3 significant figures. So AD then becomes 29.5 meters. Right. Now, if you want to change this to millimeters, you can do if you wish to do that. So if you multiply it to 9.5 by 1,000, you should get to 9,500 millimeters. And that should be our answer. Thank you for watching, and please subscribe. Hopefully, we'll see you again sometime. Bye-bye now.